we're moving now into slope fields. Slope fields are a way to think about derivatives. So for example, let's say we have dy dx equals 2. Well, if you were to think about that and integrate that, you would be getting, well, y equals, and we're saying the slope is always 2, which means we'd have something like 2x plus b. Now, you could do the derivative or the integral of both sides, but what I'm really thinking about is this is saying that the equation has a slope of 2 everywhere, and the way that that's possible is with mx plus b. Now, the thing that we don't know is the y-intercept, but what we do know is that if I were to put like a grid of points here, and if I were to think at every one of these points, what is the slope? Well, the slopes would always be 2. So I'm kind of drawing the slope at every single point. In this particular case, the slopes are not changing at all. They all have a slope of 2. And if I were to put a point right here, well, I know that this point, if I were to start here, would have to follow the grid lines like this and follow the grid lines going back. So instead of me trying to draw the situation, let's go over to Desmos real quick, where I have found a slope field generator. And I actually have the same exact situation where the derivative function is just 2 everywhere. So what does this mean? Well, you go to every grid line, and every grid line is going to give you a slope of 2. Which means that if I slide my point around here, even in between, what it's doing is calculating the slope at that particular spot, and it's always 2. So what we need to do is actually test that equation that we found, y equals 2x. Alright, it is graphing a line. It's in this particular spot, we started at 0, and the line is following the field lines. So what I think about is kind of like you're putting a particle in a field, and the field is going to take it wherever those lines are pointing. So this might remind you of like the electric field or the magnetic field. It's going to direct your particles. Also, this is kind of like gravity. If there is a gravitational force going this way, when you place a particle, it's going to follow a path given by this line. But I can do a lot of things here. If I actually wanted it to start up at 3 or 2, I would do plus 2. Now the point starts here, but it's still going to be following the field lines along this way. So our job right now is just to get a field line going. And field lines can change. So if I write the derivative equals 2x, that's going to calculate a field where, depending on where you are, the slope is going to be different. Okay? So in this particular case, what we do is we think about all these grid lines here, and we follow the instructions. For example, at point 0, 0, what is the x value? It's 0. So the slope is going to be 0. It's going to be flat right there. Same with over here. As I slide over to 1, 0, the instructions say the slope is what the x value is. So at that spot, my x value is 1, my slope is exactly 1. If I go over to here, it's 2, 0, so my slope is 2. And the nice thing about this one is it doesn't depend on y at all. So even if I go over to 2, 4, I still have a slope of 2 because my x is still 2. So in this particular case, when the x changes, your slope is going to change. So we would want to be able to get this graph by hand. Let's go back here. So how would I get this by hand? Well, on a graph, it doesn't have to be too detailed. You can have just a few points marked out. And on your homework, normally they would give, I'm going to give you a grid, so you'd be able to just jump to the points instead of drawing this every time. Let's say we had dy dx equals y. Now this is the opposite of what we just did. It only depends on the y value. So let's pick out a few points here. 0, 0. Well, at 0, 0, the slope is exactly 0. And if you think about this, over at 1, 0, the y value is 0, so the slope is still 0. So on each of these points here, when you're on the ground, the slope is going to be your y value, so it's going to be 0. So let's move up here. What about 0, 1? Well, 1 is the y value, so our slope is going to be about 1 there. And I'm filling it in everywhere here because everywhere along this line, our points are going to have a value of y equals 1, so our slope is going to be 1. And then up at 2, the slope will be like 2, so it's going to be a little steeper. Okay, and if I wanted to do 3, I'd have even steeper lines right there. And it gets hard to kind of distinguish, but you get the feeling now of how the slopes go. Same on the bottom here. If you are down at -1, you're going to have a slope of -1, -2, -3, and at the same heights, you're going to get the same kind of slopes. Okay, the great thing about this slope field generator, if we go back to that, is that we could easily go and check out work. So let's type in y, and look at that. It looks like we got it okay. So one thing that we'll start to do is, first of all, you need to make the slope field. But then you should realize that if you were to place a point like right here, where would that particle want to trace out a path? Like right here, if we're going this direction, it would kind of curve with the lines. But as it goes back here, it would want to flatten out like this. And so with that particular point, we would have a path kind of going like this. So give this a shot. Let's say that you wanted to create a slope field for y minus x. Okay, so let's do 2 in every direction. So I'm creating the points here. Alright, you should pause the video and you should give this a shot. Find kind of an estimate of what the slope would look like at each one of those points. Okay, so this is where it could get confusing because we take the height and take away the x value. 0, 0, it's easy. Because y is 0, so that'd be 0 minus 0. Well, there we go. Now over at 1, 0, if you were to plug it in here, the 0 is the y, the 1 is the x. So at 1, 0, we would get a slope. We would get a slope of -1. So it's going to point downward like that. Now, it's going to happen the same way over at 2, 0. At 2, 0, you're going to have, if you plug it into our derivative formula, it's going to be 0 minus 2 equals -2. Okay? And then let's keep going here. What about at -1? Well, 0 minus the -1 is +1, and you're going to have a kind of +2 over here. Alright, now let's keep going here. What if we went over to 1, 1? Well, when you subtract those, you'd have a 0 slope. And something you would notice here is that whenever y and x are the same, like at 2, 2, your slope is going to be flat as well, or -1, -1, because you're going to be subtracting away and getting 0. What about 0, 1? The point 0, 1, you take 1 minus 0, so the slope is 1. And actually, you'll notice a pattern here that along this diagonal, y is always going to be 1 larger than x, so you're going to have a slope of 1 there. And I'm going to try to fill out the rest of what this would look like for you guys. Okay. So over here, things kind of float up this direction. But when you cross this line here, things will kind of float downwards like this. So if you were to like place a point right here, it would want to flow up like this with the lines and kind of level off around there. But over here, this would be kind of flat and it would start turning with the grid lines. And it's going to level off like right there. So the important point is that you'd be able to get an accurate slope field, but I'm trying to show you how the curves would kind of flow through the field lines.